So let's learn low level design. I think these days in coding interviews, what ends up happening is there's a algorithms and data structures question, and there's a low level design question. What I'm going to try to do is learn low level design since I don't have a lot of confidence in it. Let me just set up an environment where I can work here. Ooh. 1 second. Okay, let's create a folder here. There's low level design folder. Okay, I have a low level design folder now. Let's open folder and that's LLD folder, right? Yeah. What's this? Don't save, it's okay. Okay, so now we have an LLD folder. Let's create a file called goal.txt, and let's see. So for this study session, essentially the goal is basically I want to have some level of I want to have some level of confidence in low level design. I know what it is. I've given interviews in low level design, but I think when it comes to confidence in giving those kind of interviews, it's still kind of low for me. For example, for algorithms, data structures, I'm pretty confident, but for low level design, I feel there is a little bit of a gap in confidence. So I think the point of this series is to build that confidence so that, if I have to give an interview today or tomorrow, I don't have to, I'll be confident in that interview. So yeah, let's get started. I think the goal is to get confidence in low level design. I think the only way to do that is through practice, right? I think that's the only way to do it. And basically what this means is get a question and then and write code for that question, right? And even if I do one question in one session, I guess if I'm able to do like maybe at the end of the day something like 10 questions, so maybe that would take about 2 weeks or something like that. Like if I do it one question a day plus give or take some buffer time, maybe it'll take 2 weeks. So write code for that question. Okay, I think I'll go with this. Now in order to do it, we need to find a question first. We need to come up with a framework to apply. The reason I am listing out that we need a framework is primarily because I think if we're doing like 10 questions and in each of those questions we use the same framework, we're gonna sort of start thinking about it in a certain manner. So we need to find a question, we need to essentially design a framework to apply, and we need to, what else do we need to do? Yeah, basically apply that framework to solve the question and tweak the framework. Okay, I think this is what we want to do. So let's design the framework first, right? So let's create another file over here called framework.txt. Yeah. So what is the goal? So when I think about the interviewer trying to interview me for a low level design round, what exactly are they looking for? They want to test my object-oriented programming concepts. So what does the interviewer want to test, right? What exactly are they looking to test? and if I can kind of deliver on those things, then I would consider it, or they would rather consider it, a positive interview. OP concepts, I think, is what gets tested in, this is specific to low level design rounds. OP concepts are definitely going to be tested. When I say OP concept, it means the, I guess, both knowledge as well as application, right? So if they ask me about some knowledge based questions, I should be prepared for that. If they ask me, so for example, when I'm writing the code, they probably want to see if I'm using these concepts while writing the code or not. They want to check the code itself, right? How the way I'm writing the code. They want to test the solution, maybe the algorithm. Actually, OP concepts are being tested. Code will probably get tested. What else? Problem solving ability, and probably communication, right? These things. Yeah, so problem solving ability is clarifying the problem in the first place. What else? Taking assumptions, going in a structured manner. I think these things, maybe even testing the code. Communication is mostly probably around if I'm able to work with the interviewer, and okay, so if I'm able to provide the right context to the interviewer, so the interviewer should be in the same boat as me and understand what am I thinking about at each point. I think here documentation can help a little bit. Documentation, ideally this will kind of get practiced as I'm making these vlogs, since it's pretty much the same thing. That here also I'm working on LLD problems, and I'll be talking about what I'm doing and how I'm tackling the problems, and it's probably gonna be similar in an interview. So I think that works out. If I am comfortable doing this in front of a camera, even in an interview, I should be comfortable doing it. So I think the first thing is, let's talk about the framework, right? Framework, what kind of a framework to use. I think for inspiration, let's kind of just look at if there are any frameworks out there. Low level, then we'll kind of make our own framework. Maybe I think it makes sense to take some components of other frameworks if we find it interesting enough. Low level design frameworks. Oh, okay, let's open a couple of tabs here and there. What is okay? What else? Low level design logging framework. Design patterns, low level design, everything you need to know, different types of low level design. Maybe we can even ask Gemini. Are there any frameworks I can use to tackle or maybe answer low level design problems? Okay, let's look at the first. Introduction, cornerstones of object oriented programming. You have background of object encapsulation, abstraction, inheritance, polymorphism. So what is this exactly? Cooking the low level design interview using OOD principles, object oriented design principles, which can help answer the question during an object oriented design round. Oh, okay, so they've already made a course. Okay, so it Yeah, so object-oriented programming, the concepts used in so this is the knowledge part of it in what I had written, OOP concepts, knowledge plus application, which was correct because even in this course there is some knowledge part, object-oriented design, UML diagrams, use case diagrams, class diagrams, sequence diagrams, activity diagrams. Oh my god. Okay, so there's probably a design over here before that, and UML class activity. To be completely honest, I don't think that interviewers are gonna be expecting exactly these diagrams, that if someone is not able to come up with an activity diagram or a sequence diagram, that they're gonna get rejected. But there should be some proper format that should be followed, which will get reflected in our framework. So I'm not gonna stress too much on exactly what these so like in the framework I'm not going to include that we need to have these things in every single question, but let's at least understand these things so that we know when they are needed. Okay, so the first one is the UML diagrams. Okay, one second, let's open another instance of Gemini and see what are UML diagrams. Standard virtual language used to design and document software systems, provides a set of graphical notations and rules for diagrams that represent various aspects of a system's structure. Provides a common visual language. Okay, you know what? UML. It's a diagram, so maybe we can just look at an image. It'll be much clearer in that. Okay, so this is a UML diagram, right? Where did that diagram go? Okay, that's the diagram. Oof. Okay, there it is. Okay, so basically the class is the variables within each class, and the review article, review body, maybe even the behaviors. Has submitted, created, is a fan of. Okay, so the entity diagrams, right? Okay. Let's see what all components are included in a UML diagram. Okay, so you have classes, you have objects, instances of classes representing specific realizations of a class. You have interfaces, contracts between, you have packages, you have components, physical elements. Okay, so it's fine. Use cases, scenarios that describe how a user interacts with the system to achieve a goal. Activities or actions performed by the system. Entities. Associations. And what about an activity diagram? Diagrams in UML are used to model the flow of activities in a system. Business process modeling, workflow design. Can you give an example? Customer places on. Oh, this is just okay. It's customer journey, essentially, right? It's a customer journey, which also talks about which classes get hit or what kind of functionality gets hit. For example, login, authentication, check, search the product, edit the product, or view reports, and then yeah, I think I understand what's going on over here. Okay, so basically there are it's a way to design ultimately the code. So framework should be, first let's understand the problem, and let's close the scope of the problem. And so we understand the problem, we close the scope of the problem, so we know that this is how much we're going to implement in, let's say, about 1 hour. Actually, Let's just to be on the safe side, let's take 45 minutes. I'm not sure how long these interviews are going to be. Even in interviews, sometimes the introduction section and takes a little bit longer. Maybe they have follow-up questions. I think 45 minutes is a good measure to take. I think 30 minutes will be a little too low, considering that these questions can be pretty extensive. So let's take 45 minutes. So we need to understand the problem. We need to close the scope of the problem / solution, you could say, or requirements actually. Scope of the requirements. What else? I think at this point we've understood the problem. We're gonna have to start designing the solution. Designing the solution in a way, right? Solution. So as part of designing the solution, we would have a couple of things, right? As part of designing the solutions, you have these UML diagrams, you have these activity diagrams. So what are these diagrams actually enabling? Let's consider that first. Designing the solution, what is the purpose of this particular step? Also, let's come over here and say that we have implementing the solution next, which kind of means coding the solution, right? And designing the solution serves, I think the first purpose it serves is probably it's basically a first step, okay, maybe a necessary step towards coding the solution. Necessary step toward coding the solution, which I think which basically means that when we start coding, when we start implementing the solution, there shouldn't be any open points of discussion. We should not have any kind of ambiguity in our minds about what we are coding. We're gonna, for example, how many classes we're gonna have, what kind of variables will be there in each of those classes, which classes will inherit from which classes, how many files do we want to have, what are the functions in each class, are we going to have interfaces. I think all of these assumptions have to be mapped out in this designing the solution phase, and once this is done, we can probably start implementing the solution without any ambiguity. I think that makes sense. So so the first objective of designing the solution is it's a necessary step towards the implementation, and the second objective is probably to communicate the approach to the interviewer, right? A lot of times what's going to happen is I mean it's happened to me before that sometimes you come up with a solution, you start coding, and in between the interviewer kind of asks you a question about something particular, and they feel like you've not taken the right approach, and they kind of try to nudge you towards taking a better approach, but till that time you've already started coding. So I think this is a good checkpoint to check with the interviewer whether we're on the right path, because at this point, if we get some validation from the interviewer that this is how it's supposed to be done, that we are on the right path, we'll be much more confident implementing the solution as well. So when I talk about diagrams and activity diagrams, let's just remove this and let's consider for me to implement the actual code, what do I need to know? I need to know what all classes are there. I need to know if there are any interfaces. I need to know the variables in each class. I need to know the methods in each class. Probably the maybe files, how many files I'm going to use. Right, classes, interfaces, variables, methods. Do I need test cases over here or not? I think test cases we can kind of keep in the end because we've closed the requirements anyways. So testing the implementation, pretty important step, I would say. Classes, interfaces, variable names, methods, files. Okay, so these are the things that we would ultimately want from this phase of designing the solution. How will we come up with classes? Okay, so when we understand the problem, basically what we're trying to do is clear any assumptions, right? And when we talk about closing the scope of the problem, solutions, and requirements, what we actually mean is actually this should be just requirements. What we mean is we need a very clear idea about what features we're supporting. So what user, I don't know what to call it, user journey. I think you could call it user journey. We used to call it user journey in product. Yeah, what kind of user journey are we supporting? What kind of features is, like, what can the user do effectively? What all, okay, who are the users and what all can they do? Yeah, let's clear that out. And then from that, once we know that, okay, these users can do this, this, and this, we'll try to get the classes and interfaces and variables and methods from that. And then we're going to start coding. And coding should ideally be the simplest step in this, because after we've designed the solution and we've kind of have like a blueprint of what we want to do, it should be straightforward to implement that as is. Although in reality, that doesn't happen a lot of times. We get confused while coding, but it's okay. I think for the purpose of the framework, this kind of works out. And then you have testing the implementation, which kind of means identifying corner cases probably, and also cases, identifying corner cases. What else do we want to do? By the way, in the requirements probably should be functional as well as non-functional, right? For example, if they tell us to design a booking system and say that, okay, multiple people should be able to book at the same time, that is definitely a non-functional requirement which we need to take care of. So functional as well as non-functional requirements, identifying corner cases as well as limitations, probably limitations, right? When I say limitations, I mean if we had to scale that up to up to a country's level or a global level, up to maybe more users, what problems are we going to experience? I think this framework looks good. Let's kind of just check out a couple of things. So this is the framework that Gemini had given. You have identify objects and their attributes. Okay, they have a subheading, object-oriented design. This is similar to R1, 2, 3, the third step in our framework. Identify objects and their attributes, define relationships between objects, define methods for objects, and create a class diagram to visualize the design. Okay, these things we already kind of have. Then you have data-driven design. Oh, these are three framework. Oh, these are different frameworks. So we are using the object-oriented design framework. Identify data requirements for the system, efficient data structures to store and manipulate the data, develop algorithms to process, event-driven design, microservices, model view controller, domain design. Oh my. Yeah, I think for our purpose, the object-oriented design works. Let's kind of just sift through these other open tabs before closing. Let's start with gathering requirements, which is correct. So our main components will be logger class. Simply now let's move to second section, which is categorization of the logs. Categorization of the logs. Chain of responsibility design pattern. Okay. Is this something they've created, or is this something which is chain of responsibility? The behavioral design pattern that lets you pass requests along a chain of handlers. Upon receiving a request, each handler decides either to process the request or to pass it to the next handler in the chain. Let's now create a simple enum to carry the values. Yeah. Chain of responsibility. 1 second. I really didn't understand chain of responsibility. let's go back to Gemini. Why is Gemini not working? Yeah, that's weird. Explain the chain of responsibility design pattern in a very simple manner. Okay, so chain of responsibility design pattern is a relay race. Imagine you have a group of runners, each with different skill. When the first runner gets tired, they pass the baton to the next runner who's better suited for the race. Pass a request through a chain of objects, each of which has a chance to handle it. If an object can't handle the request, it passes on to the next object. Let's look at the example. Imagine if you have a computer support system. First object might be a chatbot that handles a simple question. If the chatbot, okay, I get it. You pass the request to the supervisor if it's a complex issue. And you have a series of objects that can handle requests, but you don't know which object will be able to handle it. Flexible, scalable pattern. Okay, I get it. Whatever. Okay, and you have your solid principles. You have your design patterns. What is this? Oh, are these questions? Oh, nice. We got a set of questions. So I think let's kind of pick up one of these questions and basically just try to implement it using our framework. Hopefully it should tell us whether the framework is performing as expected or not, as there's some tweaking which is required, because mostly our framework is complete. I feel we have understanding the problem, close the scope of requirements, designing the solution, implementing the solution, and testing it out. Okay, so let's kind of just pick up randomly pick up something. Okay, which one seems interesting? Design a chess game. This seems pretty interesting. Design a hotel management system, Amazon online shopping system, design Stack Overflow. Oof. Designing a restaurant management system, designing Facebook online stock brokerage system, jigsaw puzzle, design an airline management system, Crick Info, whatever that is, Cricket Info, design LinkedIn, wrapping up. So there are a bunch of questions given over here. We have to probably pick one and go with it. Let's start with a relatively simple one, but designing an online blackjack game. That's interesting. So design an online blackjack, covering requirements, use case. Yeah, we could do a blackjack game. So let's create a new folder called blackjack. Yeah, let's create a blackjack game. Excited about this one. Alright, so let's copy our framework over here. Nice. So let's remove these and let's get started. First is understand the problem. What's the problem? This chapter coding requirements, use cases. Okay, so design a blackjack game. Awesome. So we'll design a blackjack game. Blackjack, if you're unaware, blackjack is a game in which it's a casino game. What happens is the dealer deals out a couple of cards to the user, and they also deal it to a dealer gives themselves some cards, and then you decide whether you want. Each card has some value attached to it. So like 2 would have 2, 3 would have 3, but face cards have a value of 10, and ace can be either 11 or 1. And basically if you go above a certain value, I'll show you. Play blackjack online. Yeah, I think it'll be a good break also. Let's play a couple of hands of blackjack before jumping into the low level design. Your game will begin after the following advertisement. What advertisement? Play now. Okay. There's an ad over here. Let's see. Man, how long has it been? I don't know when I started this. Okay. Sound from it. Yeah, I'll remove the sound. Yeah, so how the game works is the dealer has two cards, I have two cards, and then they ask me whether I want to hit or stand. Stand means, so face cards have 10 value, and number cards have the value or of the number. So this equals 10 plus 2, which is 12. If you go above 21, you lose. If you the closest to 21 wins. So right now the dealer, and you play against the dealer. So the dealer has 10 and he has a hidden card, and I have 12. Right, so after 12, if I get a face card, I lose immediately because it goes over 21. But you know, considering the number of face cards, like basically only jack, queen, king, I lose. If there's some other card, then I keep playing. Like I'll get closer to 21, so the chances of winning would be higher. So I do a hit, I get an 8. So now I reach 20, right? 10 plus 2 plus 8 is 20, and I think that's a good value. In order to beat me, the dealer would have to get 21, or if he gets 20, the pot will get split. So I stand, and he gets 14 and bust, right? Because he got 24. So I've made some money, and I mean these I'm not actually making money. These are just random values they've given. So I had about 1,000. Let's play for 350. Let's go. So this time I have 20 already. So you know, if I have 20, let's just, oh, there's a functionality called split as well. Let's learn how split works first. I'm not sure how split works. I just thought that if you have the same value, like if I had 10 10, I had the ability to split the cards. How does split work in blackjack? Splitting is a strategic move in blackjack that allows you to turn a pair of cards into two separate hands. This can be advantageous if you believe both hands have a good chance of winning. If you are dealt with two cards of the same rank, you have the option to split them. So there have to be two cards of the same rank. I'm not sure why they're allowing me to split a 10 and a queen. Ideally only two queens should be allowed. I think how these guys have implemented it is they are just choosing the value. So 10 and the queen have the same value of 10, and that's why they're allowing me to split. But I think in the rules you're not allowed to do that. You place, because of the same rank, you place an additional bet equal to your original wager on the second. The dealer gives you one card each from your hand. You play independently. Have specific rules such as limiting the number of splits or restricting hand value. When you split aces, you typically receive only one more card per hand. You draw a 10 value. Your hand is considered 21, but pays 1:1, not 3:1 at traditional blackjack. Okay. So is it beneficial to split? So I've got, you know, the thing is, if I split, I'll have a value of 10 in both hands, and I'll basically, it won't be bust, irrespective of, like I can hit both once and it won't be a bust for sure, because you know the highest value you can get is 11 and it would be 21. I think it's always, like, I think it's a better idea to split, because suddenly right now I can get a 2, but it's possible I can get a 2 and a 10 or something like that, and at least one of those hands will work. So I'll split. Choose split, which experts would recommend, while experts would recommend choosing stand. Okay. Oh, it's 20. Okay, I'll win, right? I'll stand. And Oh, okay, okay, I get it. Uh, so I was thinking in terms of I can play two hands, but yeah, if I'm already at 20, I probably have a better chance to win. Oh man, yeah. I think let's go all in. I think it's the last hand I'll play. So let's just put in all our chips and let's see what happens. I got a jack and an ace. What just happened? Blackjack. What does that even mean? Why? What? Just why did it? I think. Oh, okay, okay. The ace is okay. It considered the ace as an 11, and the jack as a 10. So I just reached 21, which can't like I basically won because of that. I thought that it would give me an option to split. Actually, no. Ace and jacks can't be split. So if I would have gotten two aces, oh, then it wouldn't have been blackjack. Okay. Yeah. Nice. So actually, I don't know. It seems too good a deal. Blackjack. I'm good at blackjack. It seems. 9, 10, 11. 11. I'll probably hit at 11. And I got 21, right? Yeah. This is so weird. I don't know why I'm. So let's see. You know, this is what happens in casinos. You win a couple of hands and then you lose everything. So in this case, I have 14. Oh man, 14 is so I have to get 7, no, 8 or above I lose, right? 8 or above. And there are like jack, queen, king, right? 11, 12, 13, 13, 8 or above I lose. Yeah, it's like a slim margin. Let's stand. Let's see. Let's hope that they go bust. Oh, dealer wins. Why did dealer win? They got 18. Huh. Okay, house wins. Okay, nice. I think through that exercise we also kind of got to know a little bit of the newer rules. So yeah, let's go back to designing our blackjack game. Understand the problem, clear our assumptions. So now we do understand how the game is played, right? So let's freeze our requirements over here. Let's keep it single player against the dealer. Let's not keep it multiplayer because I mean the objective right now is to test out a framework primarily. So let's use less number of requirements. Let's not use splits. Splitting is not allowed. So there are no splits allowed. What else? So that basically user should be able to play. Do we want to keep chips or not? Like for example, do we want the user to have a set number of chips that they can bet? I guess we could implement that. To keep it simple, we could even remove the chips and say okay, it's just it's like you can't bet anything, you just play blackjack, you either win or you lose, there's no betting involved. I guess that's simpler. Let's start with that. Yeah, no betting. Let's even remove the betting. Let's keep it like super simple for now. What else? I think that's about it, right? And it should be fair play. I think these are the requirements, and let's go on to the next phase. So we've cleared out assumptions that this is the requirements, these are things what we're gonna do. Second is we kind of freeze the scope, and oh sorry, okay, we understood the game and the problem, and then in the second part we close the requirements. Then third part is designing. So while designing, let's consider the user stories. What should the user be able to do? Right, user should be able to play. Very simple requirement. The user should be able to play. User should be able to stay or hit, and user should be able to. So in the requirements, do we want to? Okay, we are basically not keeping track of score. Right, we're not even keeping track of the score. Nothing. It's a very simple blackjack game without any betting, without anything. You just come and you play. User should be able to stay or hit. User should be able to restart the game. or it's auto restarts. We could say, yeah, game auto restarts. Right. If we see that, if we are able to complete these requirements at a fast pace, we might consider just adding more requirements from the list. But for now, let's keep it simple. Play, let's say, against the dealer. Dealer. This should be able to hit. And I think one interesting thing that I saw is when we were playing Blackjack online, when the dealer got like an 18, he didn't hit himself another time, so there was like a sort of like a soft threshold or something like that, that if they cross 18 or if they cross 19, then in that case they're not going to hit again. So there is a, let's say there's a threshold. Let's freeze the dealer threshold. What I mean by dealer threshold is that, ideally if the dealer in the two cards that they've dealt to themselves, if they get a value of like 13, they hit another time. They don't actually get an option to hit or stay. They keep hitting till they hit the threshold. So dealer threshold is frozen at 18. Let's freeze it at 18 or maybe 17. And user should be able to play against the dealer. User should be able to stay or hit. Game auto restart. So I think that's about it. So let's go on to the next, which is, okay, we still are designing the solutions. Okay, entities involved. All right, so the entities involved. How do I identify the entities involved? Should be able to play as a dealer. Should be able to stay or hit. Auto restarts. Okay. I think it makes sense to just kind of look at the nouns and see, maybe the nouns can be considered classes. I'm not sure, because user should definitely be a class, right? And then there should be a game instance which kind of facilitates starting of the game and playing the game. And actually, we should actually go into more detail. User gets dealt cards, right? How do we do this? Entities involved. I think a user needs to be a class, probably. I mean, there is an argument that can be made, because it's just a single user always. We can make do without using a user class. But no, there is a user action, right? The user action is stay or hit. So there is an action involved. But the action can be part of the game, and then we don't need a user. We're basically, it's always a single player game. So, what will the user do? We can just house the name of the user or something like that. But yeah, let's see. Let's keep the user for now, and we'll see. Do we want to keep the dealer? We want to dealer. What would the dealer even have? Dealer would have some cards, basically, and user would have some cards, I guess. There should be a game instance. There should be cards, maybe deck, card, I guess. But it is a fair game, so we can't just deal any card. We have to keep track of, like, for example, if we dealt a 5 of diamonds, we can't deal another 5 of diamonds. It's played with one deck, and that would change the odds. So maybe we keep a deck, we keep card as an instance, and the deck could be made up of cards, and then you have a game instance which starts the game, and you have a dealer and a user who are sort of playing against each other, and we take user input at some point from the the game kind of takes user input, and based on the, like, there's an initial state of the game. Let's see. So card, card is basically or card, you can just we can actually just consider card as a data type. Like, can we just consider card as a data type for this particular thing? Because like a deck would be made up of cards. Effectively it would be made up of 52 cards, but we'll have to keep track of which cards have been used. Yikes. So if the deck is made up of 52 cards, we kind of have to track which cards have been used where. Maybe we can maintain a mapping, right? We can maintain a map from those 52 basically numbers to a particular card, and we can just consider those as numbers, and randomly out of those 52 cards we're going to pick up a number and we're going to deal it, and what card actually gets dealt, that mapping we just keep it somewhere. So maybe we don't need card, right? We just need a map. We don't need a card class, we just need a map, which maybe we'll keep it in the deck, and the deck would just have the state of the deck, like which cards are remaining in the deck, which cards does it need to know which cards are dealt. Yeah, it's so this map is probably within the deck, right? So the deck kind of needs to have, oh man, okay, this is getting a little bit complicated, but it's okay. So the deck has a map of 52 numbers, and and each number points to a particular card, right? And it maintains the state of the deck. And actually we need some sort of a way to define these, because okay, we need variables and we need functions. So in brackets I'm just gonna add the variables which will be in the deck class, and below that in bullet points I'm gonna add what functions will be there in the deck class. I think that makes sense, because that same format we can use for user, dealer, and game as well. So what would a deck have? Like, for deck would have a oh man, let's call it state, and we define the type of the state as a map. Not as a map. Map is just a static instance which is there. So okay, so the map from 52 to a particular card is not really particular to a deck. This is some static data. We can keep it as part of a deck, we'll see, because we might need access to this map in other classes as well, maybe in the game class. But the deck would effectively have a state which would basically be 52 numbers, and it would need to know which of those numbers have been dealt and which have not been dealt. So is it a map? Yeah, I think this state is essentially a map with an integer which is effectively from 1 to 52, and it's equal to and a boolean, right? And the boolean represents whether it's still there in the deck or not. Yeah, I think that makes sense. The deck state represents how many cards are there in the deck. So when it starts off, the deck would have 52 cards, and suppose we dealt one of those cards, suppose some random generator we came up with 4, and we can update the deck saying that okay, this card is no longer part of the deck. So we kind of take that card and we use it somewhere else. Yeah, I think that makes sense. So we have a state. What are the variables does deck have? In terms of the information which is housed by the deck, I think state is enough, right? Do we need, like, the number of cards left is the number of cards in the deck we can keep, but there's no real point in doing that. We can derive that from the state as well if we need quick access. Like right now, if we want to see the size of the remaining deck, we can just see the count. We can go through the map and count the number of trues or false based on what naming convention we are using. to get the size. If we want quick access to the size later on, because this was going to take, yeah, it's basically constant time, right? It's because the size of the map is constant. But still, if we like, we'll have to go through 52, a list of 52 cards in order to get that information. We can keep it separate, but we'll see if we need it, right? For now, let's keep it like this. What functions need to be there in the deck? Let's see. So, when we're concerned with the deck, what do we need to do? We need to deal cards effectively, right? And assuming we are using some sort of a random, should we use a random number generator to come up with cards? Because we can't deal the same card. Like, it'll be either we come up with a random number generator to get a card, and then we check the deck, like whether that card exists, like if that card exists in the deck or not. If it doesn't exist, if it does exist, we can deal it. If it doesn't exist, then we check for another card. I don't think that's a good idea. We should be just be picking up a random number out of the already existing numbers in the deck, rather than picking up a random number and then checking the deck. Like, imagine if a hypothetical case where a lot of 2s and 3s get dealt. So if a user is like dealt 2s, and even in the future, suppose there are like 5 people playing and all of them get dealt, like 4 of them get dealt 2s and 3s, and a lot of cards become on the table, and we want to just choose another card to deal. We're not going to keep generating random numbers and then keep checking the deck whether this number exists or not. We need to have we need to have some sort of a collection over here, right? So we need to keep track of which numbers are left, at least. So how do we do that? When I think about the deck, we're never adding to the deck, right? We can reset the deck to 52 cards, but the only operation that gets performed on the deck is removal of an element, right? Yeah, removal of an element. So I'm wondering if we keep it like in a set, like a set with numbers from 1 to 52, and we remove an element from the. Can we remove an element from a set at random? Let's check that out. Because if you can do that, then I think it makes sense to just keep it as a set. So I'm using Python for this, by the way. In Python, can we remove an element from a set at random? Oh, random. Yes, you can remove an element from a set at random in Python. 2 common methods: pop, and pop method removes and returns a random element from the set. If the set is empty, it raises a key error. Nice. So we can just use set.pop, and we initialize a set to all the numbers, and then we just do set.pop. That's pretty cool. Random sample function returns list of k unique elements from the population. In this case, sample the original set remains unchanged. Okay, in this case, set the set with the removed element. So I think that makes sense. So here we keep the state, and that would basically be a set of integers, right? And the operation could be remove, take out a card or remove a card. Remove card. All right, we can remove a card. Let's keep this. Let's keep the card map. Let's call it a card map, and let's keep the card map of int to. Oh man. Int to card, I guess. Int to string. Let's call it a string. And for each string, we also would need a value. So it's not really a string. Maybe it's another structure. So let's define a data type, which is maybe card. Oh, we can just keep a card. Oh, that's why. Yeah, card is needed then. Yeah, it'll be string to card, right? So each
will correspond to a particular card, and the card, I guess, like based, like for example 4, we know that it's a 4 of clubs or something. We have to define a card object and then give it, right? And a card would have a value, and this is the value used in blackjack. So face cards will have a value of 10 or whatever, and it would have I think it would just have a value, right? And we'll modify the toString method. We'll modify the toString method to say, okay, whenever we print that card, it's going to just print out the card. So we have a card map of map into card, and we have a set which maintains the number of cards left in the deck, and this card instance can actually be passed around whatever. So, and we have a remove card function, which effectively what this does is removes and returns a card from the deck. And when I say card from the deck, I do mean an actual object of the class card from the deck. So is there anything else that the deck needs to? Yeah, maybe initialize reset. I guess a reset function makes sense. When the game ends, we can just reset. We have a card with a value and toString, and the value is an integer. I think that makes sense. The map, okay, the map is also not needed. So okay, we got our card and we got our deck. Then we kind of go to which one should we go to next? We can put a user, right? We have maybe a name, which is string. What else does a user object have? Can the user? No, how do we want to do this? Because no, I'm wondering, like. What's confusing me a little bit is that, how is this going to work? Is everything going to be handled by the game instance, or do we want a separate user instance? Do we actually, the cards, when we deal the cards, do we want the card to be attached to the user class, or do we want to just keep the cards in the game class and just maintain a map that, okay, this user has these cards, right? Because when I think about user, I don't think it makes sense for the user to have cards, right? Because it's part of the game, right? The game is sort of like an interfacing layer between the deck and the user. So I think the user just has name. In the future, if you want to add if you want to add chips, if you want to add betting value and all those things, if you want to add some bet value, we can add it to the user. But for now, I think just a user instance makes sense, right? And it's a single player game, so yeah, everything else will be handled by the game itself. And the dealer instance, the dealer doesn't require a name, and the dealer, honestly, the dealer is the dealer even needed over here? Because the dealer doesn't have a name. The dealer cards are going to be hosted in the game. So there are, probably there's, well, the only thing there for the dealer is the dealer cards. But like if we keep a dealer, like one option is to keep a dealer instance within the game, and then literally deal the dealer class a card and maintain how much value the dealer has within the dealer class, similar to how we were doing it in users. Like we could do the same thing in users, that we literally deal the cards to the user, and the user just keeps track of okay, so there are two ways to go about this. One is that the user and the dealer interact with the game instance, and the other way is that the game instance houses everything, and like the game instance contains the map of how many cards the user has and how many cards the dealer has. Let's try it by, I think one of the ways, let's kind of define the game instance first. The game instance would have I think the game instance would definitely have a deck. So we'll say deck, which is of type deck, because in order to play the game you do need a deck, and you need a I guess you need that's all you need. We can handle it in functions, or we can keep it as dealer. Okay, if we suppose we go the other way and we see dealer, we say user, which in this case is a single user, but later on we can sort of add to it and say there are multiple users. I can change this from a single variable to an array, saying that okay, the game has a dealer, multiple users, and a deck. Okay, and in it there's some reset function. Makes sense, I guess. Over here on the deck there was a reset function. So basically when the game gets reset, it should call the reset on the deck, if that makes sense. Doing this exercise has made me realize that I was right not to be confident in low level design. Because on the surface it looks pretty simple, but when you actually start implementing it, you need to be very used to doing this exercise. And to be fair, when you're actually developing code in an organization, you're not really going through exactly this exercise. It kind of revolves more around clarifying requirements from product and coding out different features and different types of things. But like, you do make these decisions, but it's not like you make these decisions in a time-bound fashion where you're just sitting and just creating them. Plus, you work with the same code base, so usually you're just adding to the same code base and reusing code. Anyway, yeah. There is an argument to be made whether this actually is a decent test, like it should be included in an interview or not. I think the way I see it, organizations like the bigger organizations like Google, Uber, Microsoft, these companies have come up with these tests and these kind of interviews, and they just take decisions on data. So what they're going to do is they're going to add this test, low level design tests, and then they're going to monitor everyone who got hired who was asked this test, and they're going to see how those people perform, and based on that performance they're going to see if it's statistically significant to say that this test worked well or not. So even though they might not have a clear reason as to why AlgoDS or why LLD or why high level design is directly related to a software engineer's ability to perform well inside the company, they probably do have data to back it up. It's sort of like A/B testing if you think about it. Even in A/B testing, what you do is you try out different branches and you use data to make a decision between which branch is better. You don't necessarily have a reason to say why that branch is better, like a reason in terms of fundamentally you don't have a reason to say why this is better. You just know from the data that it is performing better. Anyway, let's get back into it. So the game has a reset function. It has a dealer instance, it has a user instance, it has a deck. Okay, so the game, reset would automatically probably give one. It would give 2 cards to the user. Yeah, so this effectively would give 2 cards to the user and maybe 1 to the dealer, right? And there is a game state as well, because when you think about the game, one phase of the game is when we're dealing cards to the user and the user is deciding whether to hit or stay, and one phase is when we are giving it to the dealer. So I think it makes sense to have some sort of a phase here, right? And this phase can effectively be in enum, right? Phase here, which is phase, which is, let's just call it an enum, and let's say user deal, the user phase and the dealer phase, the two phases, right? The user phase and the dealer phase. The user phase ends when the user has stayed, and when the dealer phase ends, basically the game ends, right? And we reset. So we start off with the user phase, and effectively we need to give the user an option. So the game should, okay, so one thing very important over here is the toString function. The toString function within the game should print out the board, right? It should print out the entire board. What else do we need? We need an ability to take the user input in some way. So the game loop so game loop can be handled within the game itself. That's one way to think about it, or we can handle it in the main program. That we take the input in the main program and then go, but the user input is only required when a user is making the decision. So when suppose we create a game instance, we pass it a user instance, we pass it that, and then so the game would decide when to take the user input, and if the user input is needed, should the game just automatically take the user input, or should it sort of inform our main function that a user input is needed to get things further? Because we can go about it in both ways, I feel. Reset and toString. So during reset, or maybe just call it reset game. You just reset two cards onto the dealer, toString method to print out the board, and then get user input. I mean, how will it work, right? Do we want to? So basically, the game has to go on and ticks effectively. Like initially, when the game is set up, now the game should go on till the next sort of breakpoint where there is either user input needed, or the game sort of ends. And from the user's perspective, I feel it'll be kind of weird playing that. Suppose you're playing and the game asks you whether you want to hit or stay, and you click on stay, and right when you click on stay, the game ends effectively, because the next breakpoint is after the dealer deals himself the cards, and either he goes over 21 or he wins, right? So I think it would be a pretty bad user experience, because the actual simulation of the game won't really happen. So how do we do this, right? So maybe simulate game, or maybe continue game. Right, create a game instance and you call continue game, and the continue game would just keep working till there is an end state, and this would effectively handle the proper printing of the game board, right? I think that makes sense. And whenever there is an instance where a user input is needed, maybe get user input or something is needed, and you just call continue game, and the continue game, and it returns, the continue game would return, and then you would call continue game again with the user input, game instance, and get user input. See, let's open up some sort of a whiteboard. Online free whiteboard. Yeah, let's use this. Okay, so we have a game instance currently, and we're saying that there'll be a user object, and this object will be tied to this. So we basically, in our code, we're gonna go game and we're gonna pass in the user object, that okay, is this user, create a game instance with this user as input. So game has that, and now what do we do in the main instance? We have to start the game, right? Game dot start, right? The reset, we can do start game, or maybe start new game, right? We're gonna call game dot start, and this should print out the board and give an option, right? Give an option and basically take user input. Yeah, so the entire game can be simulated within the game class itself. So start new game word, yeah, and simulate the entire game, right? And within that simulation, we need a way to continue the game. We need a way to get user input. So get user input is probably a blocking operation anyways. So is continue game really needed? Handle proper functioning of the board is, yeah, simulate the game. Yeah, basically we wanted to continue game, handle proper, and handle proper board game. Yeah, so I think this can call continue game. Actually, let's call it simulate game instead. Simulate game, and start new game would effectively just call simulate game, and this entire game would get simulated over here, and we have a deck dealer user in the phase, for phase of the game, which is either the user phase or the dealer phase. Or the end phase. Let's call it maybe 1, 2, 3. Okay, 3 means that game has come to an end. Yeah, let's keep it like user dealer, and yeah, and the simulate game would, what would the simulate game do? It would print the board, get basically the next thing to do based on the phase, right? Based on the phase, it would kind of understand what the next thing is to do. Okay, this would also have a value then. Dealer would definitely have a value, right? And it would probably have cards of type list probably, and the dealer would also have some sort of cards. And then what's going to happen is, based on the phase of the game, simulate game would run the entire game till it reaches the end phase, at which time it, let's just say it comes out. It doesn't start a new game, it just comes out. So we call start new game, and honestly start new game isn't doing much. We could just say start run game, like we could just have a run game function and just remove this responsibility of handling everything over here, and all that is sort of internal. So effectively we just need this much, right? And we are dealing the cards to the user and the dealers, so we can have like a get value function or something like that, right? If we could have a get value function from the user, we could have a get value function from the dealer. Because a user entity would have cards attached to it in this case. Otherwise, the other way to go about it is that within the game, the dealer is not the dealer instance, but rather the dealer points to cards that the dealer has. So it would be cards over here, and we wouldn't have to call dealer.getValue, but rather. So how are we going to deal cards? So we probably need an add card function over here, right? Add card to the dealer's hand. Yeah, we need a add card function over here, and from the deck we're gonna the game run game, but internally I think it's gonna use a couple of functions. The run game is probably gonna need a couple of functions. It would need a get new card function, and this would be an internal function because we need to get a card from the deck and then sort of use that card. And we need to, what other function do we need? Yeah, we can add a function to the user, and this would also probably have a reset function, and this would probably have a reset function, right? I guess so. This should, right? And effectively we do run game, and at each instance of run game it's going to print out the board. It's going to wait a little while, print out the board at any given change, and then ultimately it should work. Honestly, I'm not 100% sure whether this will work. Let's kind of code it out. Let's see. So let's write simple hello world to see whether everything is working fine. LLD folder, let's go into Blackjack, Python main. Yeah, hello world works. So we do have hello world over here, right? Okay, so at this point everything is clear, so we can, hopefully everything is clear. I mean, I'm not sure it is, but let's start. We have to run before we walk. Okay, so we have a class called user. Oh man, I'm not 100% sure of the syntax. I'm sure this is how we did a input function. It has a name, it has a, I think the value is just nil initially, and cards is also sort of nil. We basically just take a name which is string, and we do self dot name is equal to name, and we do self dot value, let's set it to 0, and we do self dot cards, and we set it to an empty list. I mean, maybe this should be a tuple of 2, but yeah, actually maybe it makes sense to keep it a tuple of none, right? Because oh, it can be more than 2 cards. Oh man, it has to be a list. Yeah, it's an empty list, right? And we have a basic user class, and we would have a add card function, and the add card function would take a card instance. The card does have a value, right? It does have a value and a toString. So the, oh, that's a different value, right? Yeah, card number. Oh, we need a card number as well. The card number and the value, blackjack value. Let's call it blackjack value rather than just value. And we do have a card number which represents which card it is. toString function would handle that, right? So we get a card instance over here, and we say that self dot cards dot append. Let's do card dot oh man, card number, I guess, right? We take up the card. Do we want to save it as a string, or do we want to, like, what do we want to store here? Do we want to actually because if we want to store it as a string, we can just do string. We append the actual card over here, right? And we just print out the cards value we already have, so I think it would work. Card doesn't exist, so let's create the card class as well. Def init self. The card class has a blackjack value and a card number, so whenever we create a card, it's gonna have some value which is of type int, and a card num which is also of type int, right? And self dot value, no, it's blackjack. BJ, let's just call it blackjack. Blackjack value is equal to the value passed, and self dot card num is equal to the card num passed, right? Yeah, I think that makes sense. Then we have add cards, which it adds the string version of the card, and it also adds to the value is plus equal to self dot, not self dot, actually card dot blackjack value, right? So it's gonna get the blackjack value from the card. Update over here. One thing we can also do is keep these as private variables and have functions for getters and setters, and instead of using this directly, because we do not want the user, we ideally don't want to give the user the ability to change the value on the card, but for now let's keep it like this. I think it's fine. Today I just want to get through one question even if it's not that much optimized. Okay, user has, what else does the user have? Okay, the card will have a toString function though. I think he used to do it like this, and then we print out, we print based on the card number, right? Based on the card number we're gonna return a string. So let's, maybe it makes sense to keep a map over here, maybe like a dictionary or something like that. We do a string map, right? And within the string map we would have these numbers which would point to some value, and that value can be like, it could have I think what it would have, for example, it starts with an ace. Suppose we start with an ace and a spade. Ace, should we write the entire thing, or is there a way to spade? Oh, spade text, card symbols copy paste, that's nice. Are these like text symbols? Can I copy them? Oh no, it's not. Oh, here we have it. Oh, we can. Nice. So we got one, we got two. Oh man, this is gonna take a while, right? Because there's just one spade. Sorry, there's two of spades, and we're gonna have to define this entire thing. That's not good. Yeah, that'll be like 52 in this. Oh man. Is there a faster way to do this? I mean, there has to be a faster way, right? This is just not gonna write 52 numbers over here. Yeah, let's just write a function for it. Populate map function self, right? And it's like an internal function, and here we can say self dot populate map, right? And this was I'm just gonna populate the map over here instead. String map is an instance of card though, right? String map, yeah, nice. Okay, so for in range of 4, and we do for j, let's call this the first one, let's call it suit, and j, let's call it number, right? And let's do 13, and let's call it suit in so we want, we want it suit wise, right? So yeah, we'll do 4 and suit here. That is suit, right? Card suits suit, yeah, 4, and then we're gonna do it in the range of 52. Nice. So we got suit and we got number, and string map, let's add, right? So we have to add, oh man, what are we doing again? We have one second. We wanted to create the string for each number, right? When you populate the map, what we want effectively is that a number which points to this, by the way, would be 13, right? Jack, queen, king, yeah, be 13, and we want based on the suit and the number, we want to sort of, yeah, based on the suit and the number, we need to have a ID for that particular thing, right? And the ID would be the number plus 13 into suit, right? Because for the first suit it's going to start with 0, and let's keep it 1 to 14 maybe, because we want this to start with 1, and then because suit is 0, it's gonna just be 1 to 13, and next time onwards it will take suit as 1, and then it will be 14 to something, right? So the ID is that number, which I think makes sense. And let's key here, we do a suit map probably. Right, and this I can do, right? Because suit map is, where did the suits go? Yeah, let's, yeah, so let's do this, right? And the 1 is hearts, 2 would be diamonds, and then your 3 would be clubs. Yeah, so we got the suit map, so we'll get the suit as well, which would be suit map, and we'll just enter the suit, and we'll get more, and then we need to get the number, right? And number we already have, because this is the number. Nice. So now we can populate self dot, actually it's not self dot, it's part of the class, I think. So it's card dot string map, and we add the ID over here, and we add, oh man, we add, oh yeah, probably add the string representation of the number, and we append the suit to it, right? And this should populate our string map over here. Okay, so now we already have the string map populated, and what we want to do is we just want to print it out, right? We based on the card num, and actually do we want to return it or do we want to print it out? I think we want to return it, right? Because this overrides the toString function, and at some point we're going to just call it with a string, and yeah, we'll just return it. So we return self dot string map, and we pass in the self dot card num, and string map is a string map, so ultimately you're populating it with a string, so this should work. Right, so we do have our card class now. Nice. So I think our card class works. We should probably test it out, but yeah. Actually, we can try a quick test for it as well. If we just comment this out and we say that, okay, we create a card instance with a value, say, of 10. Oh, sorry. Let's put in any value, and let's say we have 34 over here, right? One thing to note is that it's anyways. So we create a card object. Sorry. 24, and this is basically a card object, and we say print out the object. It should give the 24th, ideally. Yeah, it failed. 1 second. So what's the problem here? There is a class card. It says that the unsupported operand type number plus 13 into suit. So this part, right? Because the suit is a number, and the number is also one number. Why can't it add to string? The suit is it's considering suit as a string. Why would it consider suit as a string? That's odd. It should have been an integer, right? Because do I redefine it? Oh, I added to suit. Oh my god. Okay, I think I got it. I think for the first iteration it works out, but then for the next iteration suit. Oh, because in this range suit becomes a string. Yeah, got it. String suit. Let's call it string suit. Huh, that makes sense. Oh, nice. We got a jack of, yeah, I'm not going to do the jack, queen, kings. It's just, we'll consider this as jack of hearts. We'll try another one. Let's do 52, the last card in the deck, which should be 13 of clubs, right? Yeah, nice. Let's just try the first card in the deck, and boom, right? I have not handled errors, by the way, but so this will probably fail. Yeah, this will fail. Awesome. Actually, I don't think we need to even handle those errors, because the user kind of never changes it, and it's like just part of the game and part of the deck. So once we set it, it will never change. Okay, so let's start with the user instance. We're done with deck. Let's finally, so let's mark it somehow, right? Yeah, I'm done. Hopefully. Then let's go on to the user. Now, yeah, we were at the user, right? And user, we had put in what? Add card. Yeah, we had add card, which appends the blackjack value, and cards are string.card. Now this string.card is gonna work, right? Because it's gonna. So yeah, this is interesting. So when we do an add card on the user, it's gonna take up a card from somewhere, card instance, and that card instance has a blackjack value and a card number. And when we call string of card, it's gonna actually call this string function, and it's gonna override the toString, and what's gonna happen is that it's gonna print out the right thing. So now all this we did just so that the add card function would work, which is fine, right? So we get what all function we get. We need a get value function. So let's implement a get value function for card in cards, and just do the results equal to 0, right? And cards is nothing, so it's self.cards probably. It's not even self.cards. Yeah, so for each card, and what are we appending to the cards? We are appending. Oh, add card appends the string version of the card. No, we can't do that. We can't do that. We have to append the card. We will have to append the card over here, unfortunately, right? Because the card instance, and yeah, blackjack value, and we are appending the card because we need the value from the user as well. So we could have implemented this a little later, but it's okay. So for each card in self.cards, what do we want to do? We want to add, right? We want to sum up the, let's call it total value rather than result. Seems a little better. And for each card, we're gonna do a get. We do have a get value, right? Oh, we don't have a get value for the card. Oh, 1 second. These are the card instances here, right? And card.blackjack value, where did we get that from? Oh, value we anyway storing, right? Whenever we append a card, we store the value. Oh, then the get value is nothing, right? It's just, we can just return self.value. That's pretty much it. Nice. So get value function is done. Not this get value, just get this get value, and then we should have a reset function, right? And the reset function effectively just resets. So nice. We are done with the user. Pretty confident. Let's just remove this. Hopefully, I think it's okay. What else is left? Dealer, game. I think the card is done, which is cool. Now we have dealer and game, right? So let's see. We have card, we have user. How did I mark 3 as done? We just have card and user, right? Yeah, deck we didn't do. Where did I mark it as done? We have just done the card and user. Let's just do the dealer. Dealer is very similar to the user, so let's just copy the user code and add it. Dealer, extremely similar. It doesn't even have a name. I think we don't really need a dealer name. We can just print it as dealer. It has value at cards. It has a add card function. It has a get value function. It has a reset function. Nice. So we're sort of done with the dealer. You know, if I think about it, the user and dealer are so similar that I'm finding it weird that we're just writing the same thing twice. Ideally, we should just create some sort of a class called player, and then the user and dealer should extend that class. 1 second. Actually, we can't do it using player, right? The user would eventually have some chips on top of it, and when we call, yeah, ideally we should be defining some high-level function, high-level class, and then extending user and dealer from that class instead. I think that makes a lot more sense. So what kind of a class can we define over here for dealer and user? Human, but I don't know. The human doesn't have a name, but like the dealer doesn't have a name. So we can maybe a player.
Like a user can be a player, the dealer is basically a player, it's a type of player. Yeah, maybe like we can define a class called player and anything a player, but okay, the dealer and yeah, the dealer is basically a player, right? In a way, the dealer is a player. It's just a special type of player. So I think we can define a class player and have these functions over there. Be yeah, and does that make sense? Let's do a quick Python how to create a parent class with variables and thirds and extend it in new classes. Forgot the syntax for this, so let's see. So the parent class we can just define as it is, and then we just add it in parentheses, and we call super.init and we pass it, and that's pretty much it, right? Yeah. Okay, so player, and this thing sort of becomes player, right? But the player doesn't necessarily have a name because the dealer doesn't have a name, and rest kind of remains the same, and this user is essentially part of player, and then we don't need these functions because they're the same functions that the player uses. But what we do need is to call the superclass, right? Super, and then we do dot slash dash init dash dash, and what do we pass in it? We just pass whatever was needed, which in this case is nothing because value and cards are not there, so we don't pass anything. We just call the superclass, and value and cards are not needed, and we have self.name. That's pretty much it. And similar to this, we can extend dealer from player, I guess, layer, and we say the player doesn't even have a name, honestly, so it's just a type of player. And yeah, there's really nothing much it's doing. All these are anyways part of generic player. You can actually use a player instance for the dealer because the dealer doesn't do anything. Yeah, we can call it a dealer and just call it just name the variable a dealer and not do anything because the dealer doesn't really have anything. In the future, will the dealer have some special abilities which are different from the player? Not sure. Also, whenever we're extending such classes, there is some solid principle. The L in solid stands for Liskov principle, and that states that whenever we do something like this, everything that the parent class is supposed to do should also be the parent class object should be replaceable by a subclass object. So if you're using player somewhere, everything the player does, user and dealer should be able to do, right? So in this case, I think it's fine because the player itself can add card, get value, reset, and the user also does all of those things. So I think it should be replaceable. The player should be replaceable by a user and by a dealer. Yeah, I don't feel right calling it user for some reason. Anyways, let's move forward. So let's move forward. Let's say that we have dealer done, and we get started on the game instance. Is it? Let's get started on the game instance, right? The game instance. What does game has? It has a couple of things. Okay, let's define init self. What does the game instance need? I think the deck, we can just sort of initialize the deck in a way. I guess we can
pass in a dealer which is of type, let's call it player. See, we can use it like this, even though we can write the game instance in a way that any player gets rejected, but I think it makes sense to keep it as a dealer here. Or we could have kept, we could have written the game class considering this as a dealer interface. That's another option. Dealer, what am I doing? User, okay, we have a user, and phase. Okay, we the enum is housed here, so we're not going to pass it here. So I think this is all that is needed. Self dot dealer is equal to dealer, and self dot user is equal to user. Okay, and we need the game where to keep the deck. Should I keep it as part of the class, or should I keep it as part of the game instance? I think it should be part of the game instance. So we'll do self dot deck is equal to deck. We will define deck, and phase, self dot phase is equal to phase. Okay, let's see how to define enum in Python. That's it. For enum, this would be phase, maybe game phase. Okay, enum, and we have 3 phases, right? We had a user, dealer, and end. So let's do that. User, we had a dealer, and we had an end. So these 3 phases we get. I guess we're calling it game phase, so this would become game phase. Okay, maybe the G should be capital, not sure. Also, we want to define a class called deck. I think let's just get deck over with before going back to game, because game uses deck. So the deck has, let's define init self wait, the set is kind of pre-initialized in the deck, right? And the card map, wait, we have a card map housed in card itself, right? So do we really need a card map in deck? So no, we just need cards, right? We actually don't even need we'll have to create cards at some point. When we're dealing, we create a card from the numbers, maybe. So set of numbers it's going to take, right? State, and that's a self-initialize. So we can take self.state and set it to a set. Python, I want to make a set with numbers from 1 to 52. Easy enough. So this is the set. So we created a set and stored it in the state. That's pretty much it. And when we do remove card from the deck, right, what's gonna happen is we have to call self.state.pop, and this would actually have the card num, right? That would be the actual card num, and we pop that card num. We have a card num, and remove a card should ideally return a card instance. And the card instance requires a value and a card num, right? A value and a card num. One second, why does it require a value? For the blackjack value, can't it make that out from the card num? It can, but it should not, because it's okay. So yeah, we can actually have the value over here itself, right? I mean, we can have the blackjack value derived from the card num itself. Ideally, we don't really need to have the value from there. Yeah, I think we should just derive the blackjack value from the card num. And let's derive blackjack value from the card num. It should be possible, right? How do we do that? So first we want to see which card it is. I think the suit doesn't make a difference. So we take card num and we do a modulo of it's ace to jack, queen, king till 13. So we get a card value. No, what do we call it? Get a card. We're already using card number, so we should use something else, right? Actually, we should be using card ID over here, but we already used card number. Let's just call it number. So we got a number. We did a modulo 13. So we got something from 1 to 13. So here if num. So because it's 1 to 13, can it be 0? Yeah, if the remainder is 0, then it's 0, right? So for it can be actually. Yeah, it'll be 1 to. Oh, it'll be 0 to 12, right? Oh, this will be ranging from 0 to 12, right? Because it could be 0. Modulo could be 0 if it's like a multiple of 13, right? So if it's 0 to 12, we want basically we want num plus 1, right? So if num is so this if num plus 1, then it basically became 1 to 13. If num plus 1 is strictly smaller than 11, because if num plus 1 is equal to 10, right, it'll be 1 to 13, and if you get it as a 10, the value is itself, which is fine. So blackjack value, let's just call it blackjack value set to none for now, and this blackjack comes over here. We don't actually pass a value, right? And self.blackjack value is equal to blackjack value, or maybe let's just call it value, because now we're not using that. Wait, were we using value anywhere? No way we were using that, right? What's the expected indented block? Oh, because of the if. Yeah, value is equal to num plus 1 in this case, right? If it's smaller than 11, what happens if it's equal to 11? Oh, it's 10, right? For 11, 12, 13, yeah, value would be equal to 10. Honestly, let's just keep ace as 1 for now. I think let's keep ace as 1 for now. Let's keep ace as 1 in blackjack value. We can change it later on if you want to, but let's just keep it as 1 for now. I think from the next question onwards, I'm going to reduce the scope even further before starting because I don't know when I started this, but definitely it's taking more than 1 hour, I feel. Anyways, so we got this, we derived the value, and now this only takes cardinal, which makes it easier in our deck, because now wait, what? Why does it make it easier? Yeah, because the deck only maintains cardinal, and the cardinal can just be passed over here, right? So the card instance, so the deck has a remove card which gets passed, and the deck probably has a reset button, def reset function self, and all it does is it sort of resets the state. That's all it does, right? Let's just, we can even add a return statement in the end, and I think deck is done. Nice. And now the game, we can come back to the game class, and now we sort of have a couple of things in the game. We had an init function in the game. We need a we need basically to modify this function, right? And we need the run game function, which is basically the main function. And when we start off, let's say we have a user object called user, and user takes in Utkarsh, which is my name, and we would have a game object, which would be game. Oh, we'll need to create a dealer as well. Actually, we don't need to pass the dealer, right? Yeah, we can just create a dealer on the go over here. We don't actually need to pass in a dealer object, right? A new instance of dealer gets created, so we just need a, what happened? Oh, because of this, let's just call a return over here for now. So we do have a user object, we have a game object. Game uses a user object, and then we call game object dot run game. It should be as simple as that, right? And then the game runs till it ends, and that's pretty much it. Okay, so we have a function called run game now. Alright, okay, and the run game basically handles the entire event loop. Yeah, I think our framework needs to get changed a little bit. The thing is, while coding, like, it's easier to, if I code and then add documentation and write better code, rather than doing it all here, because I'm not actually writing any documentation, or it doesn't look like I'm coding properly. At least it doesn't feel like that to me. I think in the framework, after implementing the solution, let's clean up code or something like that if needed, right? Because yeah, I think that step might be needed. Anyways, we come back to run game. Oh, so when we think about the toString function, what is it going to look like? What do you want to print here, right? Let's use this as a delimiter. Okay, and what we want to print is, we want to print the state of the dealer, we want to print the state of the user, and that's pretty much it, right? And the game state, current game state as well, I guess. So user state is self dot string. We call oh, I did not implement that, right? Oh man, that's so sad. Or did I? In the play, oh, I did not implement it. We need to implement we need to override the string function over here, right? So this should be, I guess, printing out the cards. right? So for card in self dot cards, and we have a string to print, right? We basically just append to this. We add the string version of card. We can do that because we did modify it in the card. Yeah, we did modify it in the card. So we can do this and probably add a comma, I guess. So it keeps adding for all the cards, and in the end I guess we can just return the string to print. Maybe without the last comma, right? So if we do this, we can do a length of string to print, so -1, right? And what this would probably do is it would pick everything except the last character, and last character is a comma, so I think this should work. And because we added it in player, the user and dealer already have it, which is good. And here we're using this as a delimiter. The user state is just strings. The dealer state is string version of self dot dealer. What to do now? We can just print the user state, dealer state, game state, maybe game state as well. State is equal to self dot phase, and the string to print is basically the user state plus the delimiter, and this is just call it string, right? I'm not sure if what gets printed in the enum. I'm a little unsure what will get printed in the enum, right? In Python, if I print the enum, what gets printed? Oh, then it's fine. I think it'll just print game phase dot end or something like that. So I think that would be okay. So why is this different color? Anyways, we get a user state dot delimiter plus dealer state plus delimiter plus game state. That's pretty much it. What happened? Experience didn't block because of the run game? Yeah, done. Okay, so now we do the run game function, which is basically the main function to control everything. We have smaller functions, I guess. We have add card, get value, stuff like that. So let's write the run game function. So when the run game function gets called, it should just run an entire instance of a game, right? And initially in our code, since we are just creating a game instance and running the game, the values are there. It's just we need to sort of play it out. So till when do we play it, right? So while the self dot phase is not equal to, what was it called, game phase dot end, so the phase doesn't become end, and this is the current phase, right? Game phase dot, it should be user because that's where it starts, right? And in the user class we have an add card function, but it's completely empty, right? For when we started, we had empty cards. Awesome. So in the game phase, we can call probably self dot deal cards, right? Def deal cards, right? And all this would do is give the user 2 cards and the dealer one card. Give the user 2 cards and the dealer 1 card. How do we do that? We take a card from the deck. So the deck has a take card function, I think. Remove card. Okay. So we do it twice, right? So for so we take card 1, user card 1 is equal to self dot deck dot remove card. So we got a card instance, right? And we took another card and we took another card. We took 3 cards, 1, 2 for the user, and this is dealer card 1, right? We took 3 cards from the deck and we did self dot user dot add card, and we passed it the this thing, right? And we call it again with the other card. I think we could also overload the add card function to accept 2 cards, but you know, for now I just want to end this code. So let's just not just concentrate on finishing rather than, you know, concentrate on quality. I just want to get done with this code at this point. Okay, so deal cards. We've given 2 cards to the user and 1 card to the dealer. The instances of the user and dealer, they keep a track of the value, right? Because when we call add card, they keep track of the value, so they already know the value, which is great. We can get the value from them as well. Is there a get value function? Yes, there is a get value function. We can get the value from the player, and we can print out the cards as well, which is nice. I think for the user, they just need to see the printed cards, and value we can just keep it inside as a game state or something like that. Okay, so in run game we dealt the cards. Okay, so we don't want to deal the cards every single time, so let's keep this outside the while loop, right? And we just say that, you know, this is basically setting, in a way we're just setting up the game, and the game loop, right? So while the phase doesn't become end, what do? Let's just return at the end, so that this is, where's this oh, because of the while. So while, okay, so we dealt the cards. Now what do we want to do? We've dealt the cards. We probably want to keep printing it in the while loop. Yeah, we want to print the, basically the game state needs to get printed. Yeah, I think that makes sense. So we print self. I think it'll automatically just call this, and Python how to wait for 2 seconds. Time.sleep. Yeah, because I don't want it to, like, basically I feel like it's important that we wait a little bit while printing out the board. Like we print and then we wait for like 2 seconds, just so that the user can see that something is changing in the game. We can keep this as 1 second also, but let's see. Okay, so while game phase does not equal end, we print out the board. We've dealt the cards, we printed out the board, and then we, at this point, the user can see the cards which they have, and they can also see the card that the dealer has. And now you have to take user input, right? Yeah. So only if, right? So let's actually, we can use a switch case statement, right? Python switch case. Kind of makes sense to do a switch case over here. Oh man, why can't I? Oh, is there no switch case in Python? Doesn't have a built-in switch case. Oh, I did not know that. That's okay. Never mind. We have to make do with what we have. If, oh, that was Golang. Golang has a switch case statement. I was wondering why I had used it a couple of days back. Anyways, so if we have to keep checking self.phase, right? Self.phase. Wait, if the game phase becomes end, it's gonna get out, right? Yeah, it's gonna get out. And here we print. Maybe we just print out game ends ended. And let's one last time. Let's just print out self. I'm not gonna go through. We can also say who won. Well, let's see. Let's just print out game ended for now. Anyways, so if self.phase is equal to game phase dot user, that's one, and then you have lf self dot phase is equal to game phase dot dealer, right? And that's the only two, right? Otherwise, if the game phases end, it's anyways gonna end. So I think that's the only two possible scenarios. Okay, so if it's the user, we have to take user input, right? But then how to take user input? Input function, yeah. Yeeps. All right, so input stay, or wait, what was it again? Hit or stay, right? Hit or stay, right? So it's gonna ask hit or stay to the user, and let's just say H or S for hit or stay, and user option. Oof, what just happened? Option, right? And if user option is equal to H, so user, I'm assuming, would have done either H or S. Usually we can add front-end validation over here, but right now I'm just doing a crude implementation to test a happy flow. User option H. If the user option is H, what we want to do is self.user.add card, right? So yeah, we want to remove a card from the deck. It's just new card. Let's just call it new card, right? We removed a card from the deck, and we want to sort of give it to the user. Nice, we give it to the user. This new card is over here, right? Else, if it's if the at this point the game could actually end at this point. Check game ending condition, right? And if it's if it's hit, then basically the game phase changes, right? At this point, game phase changes to game phase dot dealer, right? And the next time it comes, the while loop won't be end, and it will kind of get into the dealer phase. And the dealer also, the dealer doesn't take an input, right? It automatically just keeps hitting till it gets crossed, right? Yeah, so dealer will have to add another card for sure. So definitely dealer gets a new card, and we do self dot dealer dot add card new card, and here we check game ending condition. Actually, we have to keep doing this till game ends. So while is game end, game, so while not of game over, so if the game is not over, and this is probably a self function I'll have to define, right? If you keep taking new cards, you keep dealing those cards to the dealer, keep checking, right? And at some point when you do hit the game over condition, you're gonna basically reach here. Actually, we can just change the state within the game over itself, right? Because here also we kind of need to check, right? So we'll just call self dot game over here, right? And if the game is over, they'll just set the game phase to end, and the next time it'll come here while game is equal to end, and it'll just say game ended. Yeah. Def game over, right? And this needs to update the current state as well. So I think this should just is the key is checking for game over. Should it be dependent on the phase we are in, or it just I think it can just check, right? Check for user, and then it's gonna be check for dealer, right? So user value, and I think we have a function in dot get value or something, right? Get value, yeah, nice. So get value. So if user value is greater than 21, then we know that the user has gone overboard, and at this point the game is over. So what we're gonna do is we're just gonna say self dot game state or phase is now equal to game phase dot end, right? And we're gonna return. That's it. And we check for dealer, so we get the dealer value. So if it's in the dealer phase, the user did not go above, and now we check the dealer value, right? Self dot dealer dot get value, and if the dealer value is greater than 17, right? If it's greater than 17, it's ended, right? Because if it was 18, it ended. If it's because we're using what we were using as a soft threshold. Threshold is at 17, right? So yeah, if it's above 17, then it's sort of ended. Either the dealer won or the dealer lost, but at least the game has ended, right? So it's again the same thing over here. We can even combine these, I think, right? And we can say that the user value, we can just makes sense to combine these things. Yeah, so if the dealer value is over 17 or the user value is over 21, strictly game phases end and return. And once it returns, it game end. Yeah, I think it's over. I'm pretty sure when I run it, it's gonna cause some errors, but might as well try. Yeah, positional argument error, deck dot remove card, self deck dot remove card, missing one required positional argument. Wait, line 96, it's saying that self dot deck dot remove card has some issue. 96 self dot deck dot remove card has some issue. Why would it have an issue? Deck is of type deck, right? And deck has a remove card function. Huh. Call it on the deck object. Yeah, so it makes sense, right? Self.deck refers to. Oh, what is this deck? Oh, this is a class, right? 1 second, I think I made a mistake. Deck was initialized correctly, but we had to pass an object of deck over here. Yeah. Okay. Oh, nice. Okay, so this time I got dealt a. Oh, it's doing it in order. 1 second. It dealt me a 1 and a 2, and then it dealt the dealer the 3, and if I do hit, I think it dealt me a 4. It's sort of working, but it's kind of doing it in order. The game is extremely predictable. One of our requirements was that it should be fair play. So obviously this is not the that's definitely an error. We should fix that. Let's see. So how do we fix that? I think in the deck, right? In the deck function, when we do remove card state dot pop, this is happening in order, right? Huh. State is a set of a range. 1 second. In Python, I want to randomly remove an element from a set, but it's doing it in order. Refer to the following code, right? I think I can just paste out the code there, right? The reason why your code is removing elements in order is because set.pop removes the largest element from the set by default, but it's not removing the largest element, right? It's the smallest element. Anyways, it says you import random, say that you want to sample random from that and then remove the card. Okay, I can do that as well. We need to import random, so we will import random, and then in remove card we take the card num to remove. Yeah, self.state random sample, we get card remove, and in the pop function self.state.remove, we just self.state.remove. Yeah, I think card num to remove, and yeah, I could just have called it card num to begin with. Okay, some sort of a problem. Population must be in a sequence. Okay. What happened? Line 79. Random.sample self-state 1 card num is equal to remove card num. What's the problem again? Suppose I print out the card num. Which okay, for dictionary or sets use sorted of D. Oh, it did work, right? Oh man, let's see. Okay, so scoring hitters. So we got yeah, we basically won, right? So we do stay, input enter, and then yeah, the game phase changed, right? And there is a problem, like sample. There's an error. Okay, so when sample larger than population or is negative. Eeps. What does that even mean? Random.sample from a sequence. You're saying that this sample is larger than the population. So the population is self.state is set to is smaller than. Wait, what just happened? This should just remove one element, right? From the. Yeah. Yeah, I don't think I understand what's going on here. Let's see. Python, how to remove element from set at random. Oh, okay. That's why that gives a solution. Saying from Python 3.6 plus, I would simply use set.pop. Now sets are ordered and pop always removes the start. What do you think is the most Pythonic way to remove? Oh, that's why it was causing a problem. Uh, yeah, I mean, it's seems like this should work. S dot remove cells dot state dot remove card num, and then just use the card num to create a card. Oh man. It is a set though, right? Yeah, the result of num range 500. Yeah, it's correct, right? Edit is thanks to the answer and comments in the arbitrary. If you take random numbers from ah, yeah, they're recommending sub.pop only. Let's test it out with okay, suppose I do hit. Okay, let's just test it out with this and we'll see what happens. 4 5 6 7 I hit. 5 6 7 8 9 10 11 12 I hit. It says game ended, right? Why? Because 6 7 8 9 10 11 12 13 14 15 16 17 18, the game should not have ended, right? Because 18 for the user is should be acceptable. Why did the game end? the game over condition, if any of these conditions holds, dealer dot get value, user dot get value. Yeah, so I don't think it should have ended, right? Where did it end? Let's print out the dealer and user values over here. User value, dealer value, and let's add a statement here so that I can identify it. I wonder what happened. Okay, so I do a hit. Okay, yeah, so that's the problem. The user value, it's taking it as 10, and the dealer value is taking it as 3. Why would that happen? Like if I hit again, yeah, it became 16. So initially when it checked after the hit, it probably added 4, 5, 6, 7. It should have checked it as 7. I'm not sure why it checked it as 10. Right? So you remove a card from the deck and you add a card to the user and you check if the game is over, right? So add card, friends, card dot blackjack value. Is there some problem in how I'm calculating the blackjack value? Card number modulo 13, yeah, should range from 0 to 12, right? If you have 1 modulo 13, it should be 1. Because modulo 13 into 0 is 0 plus 1 is the remainder, and oh, there's some problem over here essentially. So when you do card number modulo 13, the num does range from 0 to 12, but if it's 0 does not, yeah, basically the value I cannot take as num plus 1, right? If, like, for example, if I get 1, which means I got 0 over here, because 0 doesn't necessarily exist. So if I'll get 0, that becomes 1. Yeah, that could cause a problem. Okay, I think this function is a little incorrect. We do a card num modulo 13. So how do we fix this function, right? We have card num based on the card num value we're going to decide, right? Right, so if the yeah, I think there are two scenarios here. That if my card num is actually smaller than 14, jack is 11, right? Jack, queen, king, 11, 12, 13. So if it's smaller than 14, actually if it's small, no, if it's okay, if the card number is smaller than 10 or smaller than probably 11, then my value is equal to the card num itself, right? Sorry, right? Else in the scenario it's actually greater than 11, I was doing a modulo with 13, but the problem over there is the zero is getting counted incorrectly. Like when I do card num modulo 13, 0 does not represent the first one, right? Like if num is equal to 0, then the value is something else. Actually, I can use the same thing. I think I just have to tweak the logic a little bit probably. Yeah, I think the modulo function is fine. It's just that I have to add a condition here. If num is actually greater than 0, because the num lies between 0 and 12, so if num is not 0, if it's greater than 0 and num is smaller than 11, then value is equal to num, right? And we have an else if condition where num is actually equal to 0, in which case your value is considered 10, because it's a multiple of 13, right? So it's basically a king. Yeah, so I think we can even remove this. So only in the scenario where after the modulo the value is somewhere between 1 and like basically 1 inclusive and 10 inclusive, which means 0 to 11. In those scenarios it can be the same. Even if we keep it this as 10, it won't matter. Okay, I think I understood what the problem was. Oh, one sec, the game isn't ended. Let's start it again. Phase 1 hit or stay, I hit, and this time it did count it as 4 5 6 7. Nice. Hit 12 5 6 7 8 9 10 11 12. Hit, it counts it as 6 plus 6, sorry, it was at 18, which is correct, right? Because 4 plus 2 is 6, 5 plus 1 is 6, 6 3 is 18. Yeah, 18. And when I hit right now, the game should end. The game should end, which is correct because it crossed 21, right? The other way about it, if I do a hit and oh shit, I did a double hit. Yeah, one second, there's some problem over there. If I do a hit, then I do another hit, right now I'm at 12. I do one more hit, I'm at 18, and here I do a stay. Now what just happened? That should have worked, right? Okay, it was at 6 with the value of 3. 7 plus 3, it actually reached 10, and then it added 8 to it, got 18 18. Actually, when it reached 18 18, at that, like, it did it not consider an ending condition? What just happened? Ideally, I think it should have just considered like an ending condition over there. Let me just check. Okay, if the user option was H, then you remove a card, add a card, and check game over condition. If in the so if it's not H, then we just change the phase, and it goes here, it prints, it sleeps, and in the dealer phase it goes here. Oh, in a while loop it checks. If not of self game over, doesn't game over return anything? Oh yeah, that's the issue. Yeah, so game over has to return true, right? If not of game over means game over is false. So once game over returns true, it will go out. Yeah, I forgot to return the boolean over there. I think at this time, let's try it again. So that's gonna hit once. Let's hit it another time. We're at 12. Let's hit another to get it at 18. And here we're going to stay. And after 2 seconds, keep. Okay, the game ended at 18 18 because it crossed the soft margin, which is basically true. The game should end at that point, right? But it didn't print the board. That's the problem. It should have printed the board also. I understand. So this time it's calculating it correctly, so we don't need this, but we do need to print the board. So over here, it's taking a new card, adding it to the deck, and checking game over. Right? It's not really printing the board, so it needs to do this thing, but it needs to give some time to for the user to understand what's going on. Right? Let's try this again. Yeah. And this time straight away I'm gonna hit stay. Yeah, this time see, it added a 4, it added a 5, it added a 6, and yeah, the game ends. Oh my god. So there we have it. This was the first, I think the first video in this series. The idea of this series is basically that, you know, I am also going to learn low level design, and it's not a series where I'm actually teaching you low level design, but rather I'm learning, and through the decisions that I'm making and through the way I'm learning, hopefully you'll also be able to learn a little bit about how this works.